How do unit conversions affect the first law of thermodynamics? Imagine trying to solve a puzzle where the pieces don't quite fit because they are measured in different units. That's what happens when we work with the first law of thermodynamics without paying attention to units. The first law says that the change in a system's internal energy equals the heat added minus the work done. It's a simple idea, but how we measure heat and work really matters. If you use different units for heat and work, your calculations can go wrong unless you convert everything to the same units first. Think about energy units like joules, kilojoules, calories, or British thermal units. These are all ways to measure energy, but they're not interchangeable without conversion. For example, if you have heat in kilojoules and work in joules, you need to convert one so both are in the same unit. Otherwise, subtracting or adding them won't give you the correct change in energy. This is why consistent units are key to applying the first law accurately. Sometimes, the first law is used on a per unit mass basis, like kilojoules per kilogram. If you want the total energy change, you multiply the specific energy by the mass. Here, converting units involves making sure the mass and energy units match. If you forget, your total energy calculation can be off. Work and heat can also be expressed as power, which is energy per time, like watts or kilowatts. When rates are involved, you need to convert power into total energy by multiplying by the time period. For example, if heat transfer is given in British thermal units per hour, but your calculations are in kilojoules per second, you have to convert the units so they match. Sign conventions are another thing to keep in mind. Usually, heat added to the system is positive, and work done by the system is positive. But if you mix units and signs, you might misinterpret the results. Proper unit conversion helps prevent these mistakes. In practical terms, converting units allows engineers and scientists to compare different systems easily. For example, converting heat transfer rates from British thermal units per hour to kilojoules per second makes it easier to work with other C units. Similarly, converting work from foot-pounds to joules ensures everything lines up correctly. To sum up, unit conversions don't change the core idea of the first law of thermodynamics. They just make sure your calculations are correct and meaningful. When you handle units carefully, you can confidently analyze heat engines, refrigerators, chemical reactions, and more. Proper unit management is the bridge that connects the law to real-world problems, making it accessible and useful in everyday applications.